Well, Islam Abdullah. So, am I audible, everyone?
Yes, sir.
Okay. So, we have finished this derivation of interference in the last class. So, let's recall it. So, Mariam, what does interference means? Mariam, what does interference means? Noor, what is interference?
So it's a redistribution of light energy due to superposition of light waves from coherent sources.
What are coherent sources, Sania? Yes, Sania, what type of sources are coherent? What do you mean by coherent sources? Faisal, you were in the last class, na?
Yes, sir.
So, Faisal, what are coherent sources? What type of sources are coherent?
Sir, current sources are sources emitting light waves of same frequency and constant phase difference.
Yes. Same frequency and phase difference should be constant. They are coherent. And then we did this derivation. In this derivation, we take two coherent sources. This is first source. This is second source. The wave coming from this source have an amplitude A. And the wave coming from this source have an amplitude B. The phase difference between the two waves is phi. So you can calculate the resultant amplitude in this way. The resultant amplitude is root over a square plus b square plus 2ab cos phi. This is the resultant amplitude or amplitude of the resultant wave. A is the amplitude of first wave, B is the amplitude of second wave, and phi is the phase difference between the two waves. So that is resultant amplitude root over a square plus b square plus 2ab cos phi. That was the first result that we have derived. Along with the amplitude, we can also calculate the intensity, which is I1 plus I2 plus 2I1 I2 cos phi. So before moving further, let's do some straight formula based questions on these two numbers. So the question says amplitude of light waves
Sir.
yes.
Sir, in that I1 is equal to K square, what is K?
K is some constant.
Constant.
This depends upon some characteristics of the source, like shape and size of the source. That's K.
Okay.
Amplitude of light wave from two coherent sources are like for the first, the amplitude is 3 Newton per coulomb, and for the second wave the amplitude is 6 Newton per coulomb. Phase difference let's say phase difference is pi by 6. Calculate amplitude of resultant wave. Need amplitude of resultant. So this 3 Newton per coulomb is for first wave, 6 Newton per coulomb is the amplitude of second wave, and the phase difference is pi by 6. So in this particular relation, like for this type of relations, you have A, which is 3, you have B, which is 6, You have this phi, which is pi by 6, I think. Get the value of resultant amplitude. Use this formula one. Get the value of resultant amplitude. Do it. Answers. Abdullah, Noor, Faisal.
Sir, doing.
See, you have amplitudes, right? You have amplitudes, you have phase difference. Just have to calculate the amplitude of resultant wave. Mariam, Amalia. Amalia, you were not there in the last class. Did you went through the recordings?
Yes, sir.
It's okay. So you have amplitudes, you have phase difference. Just put all values in this equation. A is 3, B is 6, 5 is 5 by 6. Okay, Noor. Okay, Abdullah. I will just check your calculations. What about the rest? Mariam, are you doing it? I'm waiting for your answers. Huh? Okay. I got answer from Abdullah, Noor, and Faisal. Mariam, Amalia, Sania. Sania, can you hear me now? It's okay. Okay. Okay, Amalia. So only Mariam, Sania, you two are left. See, the calculation is straightforward. You have A, which is 3 Newton per coulomb. You have B, which is 6 Newton per coulomb. You have phi, which is pi by 6. You need R, which is root over A square plus B square plus 2AB cos phi. You just have to substitute the values here. A is 3 square, B is 6 square, plus 2 into 3 into 6 into cos pi by 6. So your R is root over 9 plus 36. Pi by 6 is half. Not half. Pi by 6 is root 3 by 2. So it will cancel out. This will be 18. So we have 36 plus 9, which is 45. Plus 18 root 3. This much of Newton per coulomb is the resultant amplitude. It's root 45 plus 18 root 3 Newton per coulomb. Note it down. Mariam and Sania, written. Mariam, noted. Sure. So this is how we can calculate the amplitude. Now, next we have to calculate the condition for maximum amplitude and minimum amplitude. So you can say now we have to derive condition for maxima or bright fringe. Maxima or bright fringe. We need condition for maxima or bright fringe. Or you can also call it as constructive phase difference. Constructive interference. For maxima, bright fringe, or constructive interference. So constructive interference means if I use this equation, R is root over A square plus B square plus twice of AB cos phi. Now I need condition when this R is maximum. I need condition for R to be maximum. For capital R to be maximum. So capital R is maximum if cos phi is 1. Your cos phi should be equal to plus 1. Your cos phi is 1, which means your phi phase difference is either 0 or it could be 2 pi, it could be 4 pi. Means odd, all even multiple of phi will give you cos phi equal to plus 1. Or you can write this as 2n pi. So this is the condition. The phase difference phi should be equal to 2n pi to get the maximum amplitude, or the condition of maximum amplitude was also known as bright fringe. See, we have discussed interference experiment in the previous class. So these are the bright fringes, right? So if you want this bright fringe, so the phase difference of light waves from the two sources should be 2n pi. If phase difference is 2n pi, then you will get a bright fringe. So now we have phase difference for the bright fringe. Your n will start from 0. N could be 0, 1, 2. 0 means central bright fringe. N equal to 1 means first bright fringe and all. So this is the condition of phase difference for bright fringe. After phase difference, we also need path difference. So Faisal, do you remember any relation between phase difference and path difference? I think we did this in the last class. Do you remember any relation between the phase difference and the path difference?
So delta pi is equals to lambda phi by 2 pi.
Delta x is the
Yeah, delta x.
path difference. Delta x was lambda over
Phi
2
by 2
pi.
pi.
Yes, into phi. So when we substitute these values, delta x will be equal to it's lambda over 2 pi into phi, which is 2n pi. So see, this 2 pi will cancel this, and you are left with n lambda. So the part difference is delta x, which is equal to n lambda. So and n, as earlier will start from 0. So if you have two waves, they are reaching at a point, and over that point, if phase difference between two waves is 2 and pi, and part difference is n lambda, then you will get maxima. X vessel, this is x, delta x. That's the part difference, delta x. So now we have part difference and phase difference for maxima to it. Then we will try to calculate the amplitude. Do it and tell me if you have doubts in any step. Yes, everyone written? Sania?
Yes, sir, done.
Written? Everyone?
Yes, sir.
Okay, so now you know that for the maximum amplitude or the bright fringe, your phase difference should be 2 and pi, and your part difference should be this much, n lambda. Now we need the value of maximum amplitude. So let's call this as equation 1. Let's am I audible?
Yes, sir.
Yes, sir.
So for maximum amplitude, that is R max, you can do one thing, like this is the amplitude for all phases. But if you want the maximum amplitude, then put this value where phi is equal to 2 and pi. So when you substitute 2 in 1, you will get R equal to it's a square plus b square plus 2ab cos. Instead of phi, you can substitute 2 and pi. Now we know that cos 2 and pi is equal to 1. So this is R max. So this is R max. So your R max is its root over a square plus b square plus its 2ab. Or you can say that your R max is root over its a plus b whole square. See, this whole square will cancel the root, and you will get that R max is just a plus b. This is the maximum amplitude, it's a plus b. R max is a plus b. Amplitude of a plus amplitude of b is the maximum amplitude. Similarly, we can calculate intensity also. See, the relation of intensity, resultant intensity was I1 plus I2 plus 2 root over I1 root over I2 cos phi. What is the value of phi for maximum intensity? Sania? If I want maxima, what should be the value of phi?
Zero.
Okay. And more values of phi? 0 is correct. And
Infinity.
not infinity. See? 0. And then what was the next value?
2 pi.
Or
4 pi.
and in general?
2n pi.
So what's the value of phi for the maximum?
2 pi.
2n
2n.
pi. So let's substitute these values here. So your IR is it's I1 plus I2 plus 2 root over I1 root over I2 into cos 2n pi. How much is cos 2n pi?
1.
1.
1.
So your or you can say this is the maximum. This is the maximum intensity. So this is the maximum intensity Imax. So Imax is I1 plus I2 plus 2 root over I1 root over I2. Amalia, is this term square of anything? Does this term remind you of the square of something? Yes, Amalia. Is it the square of any term? Whole square of something? Check. If you can express it in terms of square of something, whole square of something. Yes, Amalia.
I1 plus I2.
Not I1, root I plus root I whole square. If you open the square, it's a square plus b square plus 2ab. So this is the relation for the maximum intensity. See, you can write maximum intensity in one more way. You can write your max intensity as k times R max square also. Or you can write that maximum intensity is k times a plus b square. This is also one relation. So these are the relations here. Phase difference is 2 and pi. The relations that you have to remember, it's phi is 2 and pi for the maximum amplitude. Part difference is n lambda for the maximum amplitude. Maximum amplitude is a plus b. Maximum intensity is k times R max square, which is k into a plus b square. Maximum intensity is root over I1 plus I2 the whole square. And all these things are valid only if your phi is 2 and pi and your delta x is n lambda. So you have written up to here. Yes, written. Can I scroll it further? Yes, Abdullah. Can I scroll it further?
Yes, sir.
Yes, written.
Yes, sir.
So these were the conditions for the maximum amplitude and maximum intensity. This is phase difference. This is part difference. This is formula of maximum amplitude, formula for maximum intensity, another formula for maximum intensity. So highlight these relations for numericals. You should remember all. You have to remember all these things. This one, this relation, this one, and this one. Now, just like maxima, we can do our calculations for minima also. Conditions for minima. Minima. Or you can say dark fringe. Or destructive interference. So this is the expression for amplitude. R is root over its a square plus b square plus 2ab cos. This is the expression. For minimum amplitude, this cos phi should be minimum. Mariam, what's the minimum value of cos phi? For minimum amplitude, cos phi should be minimum. What is minimum value of cos phi, Mariam? See the maximum value of +1. What is minimum value of cos phi? Sania, what's the minimum value of cos phi? Abdullah,
Sir, -1.
minus. So for your minimum amplitude, your cos phi will be minus. See, this is the minimum value, okay? The maximum value of cos is +1 and minimum value is -1. Now I need angle, the angle for which your phi is -1. So cos phi is -1. This implies that your angle should be 180 degree, which is pi, or 3 pi, or 5 pi. So your all odd multiples of phi will give -1. Or in general, you can write this as this is 2n minus 1 pi. You can write this as it's 2n minus 1 pi. So you can say that your phi is 2n minus 1. That your phi is 2n minus 1 pi. This is the phase difference, 2n minus 1. So in destructive interference or in right fringe, your phi was 2n pi. Phase difference was 2n pi. But for dark fringe or destructive interference, your phi is 2n minus 1 pi. Dark fringe is this one, this image. When we say this one, that light will cancel light and you will get a dark spot. When we say dark spot, the condition for getting a dark spot is your phase difference should be 2n minus 1 pi. Let's call this as equation 1. I call this as equation number 2. Now I need part difference. I need part difference for destructive interference. So the expression of part difference is this. Part difference is it's lambda over 2 pi multiplied by the phase difference. That is equation number 3. So you can substitute 2 in 3. When you put 2 in 3, you will get part difference is it's lambda over 2 pi into phase difference, which is 2n minus 1 pi. Delta x is 2n minus 1 lambda over 2. This is the part difference. Let's call this as equation number 4. This is the part difference for your destructive interference. It's 2n minus 1 lambda by 2. So this is the phase difference, and this one is the part difference, 2n minus 1 lambda by 2. The next thing is, I need the value of R. Just note it down, then we will calculate the value of R, the minimum amplitude. Tell me once you have written. Written? Can I scroll it?
Yes, sir. Done, sir.
Sure. Faisal, noted?
Yes, sir.
After this part difference, the next thing is you can calculate the minimum amplitude. I need the value of minimum amplitude. Now, to get minimum amplitude, what we can do is, instead of this phi, I can substitute 2n minus 1 pi. So I can substitute 2 in 1. We can do the substitution. We can substitute 2 in 1. So when we substitute 2 in 1, we get that the minimum amplitude is root over a square plus b square plus 2ab cos phi cos 2n minus 1. And how much is cos 2n minus 1 pi, Amalia? Yes, Amalia. How much is cos 2n minus 1 pi?
Cos phi.
2n minus 1, the value of cos 2n minus 1. See, we have written that cos phi is minus 1 if phi is 2n minus 1 pi. So cos 2n minus 1 pi is minus 1. So when we do substitute all these values, we get R minimum is root over, it's a minus b whole square. The square will cancel this and you will get that R minimum is a minus b. So we have R minimum, which is a minus b. Okay, after R minimum, can we calculate this time minimum intensity? Yes, Noor. Can you get the value of R minimum intensity using this R minimum?
Yes, sir. K into R minimum square.
K into R. And how much is R minimum? That's a minus b. So it's K into a minus b whole square. This is the minimum intensity, which is K into a minus b whole square. We can do one more thing for intensity. See, the expression of intensity is this, resultant intensity. This is the expression of resultant intensity, which is I1 plus I2 plus 2 root over I1 root over I2 is cos phi. So for minimum intensity, I need cos phi to be minus 1. So the minimum intensity is I1 plus I2 minus 2 root over I1 root over I2. Sanya, can you write this as square of something? Yes, Sanya. Is this term square of anything? You can take help from the previous section. It's square of root I1
minus I2.
minus root I2 square. Okay, noted. So condition for minimum amplitude. Okay. Written?
Yes, sir.
Okay. The next thing is, in few questions, he may ask you to calculate the ratio of maximum and minimum intensity, I max by I min. For these type of ratios, prefer the expression in terms of amplitude. This one. I max was this k times a plus b whole square. This one. So I will use k times a plus b whole square. I minimum, which is k times a minus b whole square. So k will cancel this k. So I max divided by I minimum is a plus b whole square over it's a minus b whole square. This is the ratio of maximum intensity and minimum intensity, a plus b whole square by minus b whole square. After this, the next thing that you should know is, see if I take a double slit. This was a double slit, the double slit experiment that we have studied. This one double slit experiment. These are the double slits. So the width of these slits will decide the intensity of light. Wider the slit, greater would be the intensity of light. So the intensity of light coming from these slits, this light, these lights coming from these slits, the intensity depends upon the width of slit. So in some questions, the width of slit may be given. So you can write this as the width of first slit is W1. Width of second slit is W2. So the ratio of width of slit is equal to the ratio of intensity of light coming from these two slits. Or you can write this as Ka square, I1 as Ka square, and I2 as Kb square. So this is the ratio. So the ratio of width of two slits is equal to I1 by I2, which is Ka square by Kb square. So this K will cancel this K. It's A square by B square. This is it. So you use this expression in many numericals. Instead of I1 by I2, it will give you W1 by W2. So if you know W1 by W2, that means you know the ratio of I1 and I2. Note it down. Let's do a few questions on this concept. Written?
Yes, sir.
Okay. The next question is, Yes, Abdullah, I should get finished. So the amplitude of light from two sources are A and 2A. From first source, the amplitude of light is A, and from the second source, the amplitude of light is 2A. I need calculate first part. Amplitude of maximum, second part. I need amplitude of minimum, third part. Intensity of maximum, or do one thing, calculate ratio of intensity of maximum and minimum. Ratio of intensity of maximum and ratio of intensity of maximum. Do it. See, this is formula based thing. Sania, I should get your answer now. Huh? Your A is A, and instead of B, it's 2A. Right, no, first part is correct. Second is also correct. Right, all are correct. Yes, Amalia. Amalia, Abdullah, first, second, third, all are correct. Amalia, just check your first part. You need maximum amplitudes, so you have to add them up. Na? Yes. Faisal, it should not be negative. Just subtract the smaller one from the greater one. Huh? The rest is correct, Faisal. Mariam, Sania. Okay.
Sir,
Yes.
sir, amplitude cannot be negative.
Yeah, amplitude can't be negative. So in the first form, the amplitude of resultant. Good, Sania. All are correct. The maximum amplitude is the sum of these two amplitudes. Just add 2 and A. So we'll get 3A. That's the maximum amplitude. For the second part, our minimum. Just subtract these two amplitudes, 2a minus a. So we'll get a. In the third part, you need ratio of maximum and minimum intensity, I max by I min. So that is k times, not k times, so it's just a plus b square by minus b square. So it will be a plus 2a square divided by 2a minus a square. So that's 9a square over a square gets cancelled out. So it will be 9 by 1. So the ratio is 9 by 1, the maximum versus minimum intensity. Any doubt here in this part? No issues? It's okay. Almost everyone was correct. Next question. Now, instead of these amplitudes, he can give you the ratio of width. He can give you this question, that ratio of slit width in Young's double slit experiment is 9:4. This is the ratio of slit width. See, ratio of slit width means W1 by W2 is given. If you have W1 by W2, that means you have I1 by I2. That means you have A square by B square. Calculate ratio of minimum and maximum intensity. The ratio of slit width is given. I need the ratio of minimum and maximum intensity. Do it. I'm repeating again, W1 by W2 is given. That means I1 by I2 is given. A by B is given.
It is A by B or A square by B square?
A square by B square. So if you have A square by B square, take roots on both the sides. Okay, I got answers from Faisal, Abdullah, and Amale. Amale, just check your calculation. See, Amalia, the ratio of width is Abdullah, it seems correct. is the ratio of A square and B square, not A by B. So you can get A by B from here. Faisal and Abdullah both are correct. See, W1 by W2 is A square by B square, which is 9 by 4, which is equal to 9. So you can say that A by B is 3 by 2. So if you have A by B is 3 by 2, that means you can say that your A is 3 by 2 times B, or your A is 1.5 times B. So you need I max, good Sania, by I minimum, which is A plus B square, A minus B or B minus A square, which one is greater? So A is A, B is 1 point, sorry. Instead of A, I can write this. A is 1.5. So for A, I wrote 1.5 B. Then I write B whole square divided by A is 1.5 B minus B whole square. So 1.5 B plus B is 2.5 B. Whole square divided by its 0.5 B whole square. So I have this terms 2.5 B divided by 0.5 B whole square. So this B will cancel this B. 0.5 will cancel this 5. You will get 5. So it's 5 square by 1, which is 25. So this is the ratio 25. Sania, you have written 1 by 25. That's the ratio of minima to maxima. I need maxima to minimum. So 25 by 1. Amalia, is it clear now?
Yes, sir.
Okay, just note it down. Okay, one last numerical of this concept. So in Young's double slit experiment, intensity of light at a point on the screen, where part difference is lambda is k units, where path difference is lambda is k units. Find intensity at point where part difference is lambda by 4. Do it. You have 3 minutes for this question. See, in Young's double slit experiment, both if nothing is given about the source, then you can assume the sources are identical. Means I1 is equal to I2. In the original Young's double slit experiment, Young's takes both the slits of equal width. So the intensity of light coming from both the slits is same. Do it. So it's not that straightforward. In the earlier numericals, you were calculating the resultant intensity, right? I was telling you to get the value of resultant intensity, this one. But in this question, resultant intensity is given. Resultant is K. First get the, and part difference is lambda. You have part difference, get the value of phase difference first and calculate I1 and I2 in terms of K. Then you will calculate it further. First, get the value of I1 and I2 in terms of K. Okay, I'm telling you the expressions also. See, this is the expression of resultant intensity. See, the maximum intensity is not given. This is the resultant intensity, which is in this question, it's K. I1 and I2 both are equal. You need the value of phi. To get phi, you have part difference. Using part difference, get the value of phase difference. Very good, Noor. I1 and I2 is correct, right? Now, once you have I1 and I2, apply the same relation. No, Sania, it's not. No, no. Get this, apply the same relation and get the value of resultant intensity when you part difference lambda by. Right, Abdullah. Now get the resultant intensity.
Sir,
Yes.
sir, for the resultant intensity, phase difference will be same as
No.
that in the.
The part difference is lambda by 4.
Oh, yes, sir.
Just one more minute. After this, I will solve. Okay, let's do it. See, in this expression, the resultant intensity, the expression of resultant intensity, which is I1 plus I2, 2 root I1 root I2 cos phi. I1 is equal to I2 because it's a Young's double slit experiment. So unless it is mentioned that intensities are different, you will assume that both the intensities are same. I1 is equal to I2. Part difference is lambda. If part difference is lambda, then we'll write phase difference is lambda. I need phase difference. So we can write part difference as it's lambda by 2 pi into phase difference. 2 pi into phase difference. So you can write that your phase difference is part difference into 2 pi divided by lambda. So you have phase difference, which is x, which is lambda given. Say this is first equation. I call this as equation number 2. I'm substituting 1 into. When I do the substitutions, I get phi as x is lambda into 2 pi divided by lambda. So lambda will cancel lambda, and you will get that phase difference is equal to 2 pi. That is equation number 3. Now you have phase difference, and it is given that resultant intensity I is equal to k. That's equation number 4. Substitute 3 and 4 here. So your I is k, so you can write that k is I1 plus I2 plus 2 root I1 root I2 into cos 2 pi. Say cos 2 pi is 1. And I1 is equal to I2. So instead of I2, I can substitute I1 here. So I get k is I1 plus 2 root I1 cos 2 pi is 1. So you can write k is 4I1. So I can write I1 is k by 4. This is I1, which is k by 4. Now, once you have I1 and I2 is also equal to k by 4. So we get the value of I1 and I2. Now, he's asking to calculate resultant intensity. Again, you use this relation I1 plus I2 plus 2 root I1 root I2 cos phi. You have to calculate this resultant intensity again, but now the part difference is not lambda. Now the part difference is lambda by 4. For this part difference, get the value of phase difference. See, this is the relation between phase difference and part difference is x into 2 pi by lambda. So that is x into 2 pi by lambda, which is lambda by 4 into 2 pi by lambda. Lambda will cancel this lambda and you will get pi by 2. So when you put these values here, this value and I1 and I2 that we calculated from the last section, which is k by 4. Let's substitute these values here. Your resultant intensity will be k by 4 plus k by 4 plus 2 root k by 4 root k by 4 cos pi by 2. Cos pi by 2 is 0, so you get k by 4 plus k by 4, which is k by 2. So you get resultant intensity as k by 2. So this is the resultant intensity k by 2. Do it.
Yes, sir.
Yes.
So the final answer is k by 2, right?
Yeah, final is k by 2. Okay. So that was the last question on this concept. The next is Theory of interference fringe. See, in theory of interference fringe, we have to calculate the width of the fringes. Like in this experiment, in Young's double slit experiment, these were the fringes. Now we have to calculate the width of these fringes. This width. We have to calculate this width of fringe. This width of fringe we have to calculate. So again, we're supposed to draw this one, Young's double slit experiment. This is the source slit, single slit. Then we put a double slit in front of it. This is the screen. Now we will take separation. The separation between the two slits, slit S1 and slit S2, we call that separation as D. This small d is the separation between the two slits. And the separation between slit and screen is capital T. This is screen. This is double slit. And this is the single slit. This is D by 2. This is also D by 2. So this is the point where we get central maximum. This is the point where we get central bright fringe, or we call this as central maxima or central bright fringe. This is your central bright fringe. Over this point, there is some fringe over this point. Some bright fringe or some dark fringe. The separation of this fringe from the central maxima is nth, yn. This is some nth fringe. This could be any fringe. It could be a dark fringe or it could be a bright fringe. It could be any fringe. So you have to calculate the value of this yn. You're supposed to calculate the value of this yn for which this fringe is a bright fringe. And you're supposed to get the value of yn for which this particular fringe is a dark fringe. You need value of yn for which this is a bright fringe, and value of yn for which this is a dark fringe. So what is yn? Separation of nth fringe from central bright fringe. From central bright fringe. This is the separation of nth fringe from the central bright fringe. I need this yn. See, earlier we wrote the value of bright and dark fringes in terms of phase difference and part difference. We wrote that part difference is n lambda for bright fringe and part difference is 2n minus 1 lambda by 2 for the dark fringe. But now we need the condition of bright and dark fringe in terms of this separation. It's not the part difference. It's just the separation of this particular fringe from the central maximum. This is why it's separation of nth fringe from central bright fringe. So here, the light rays reaching at this point are coming from S1. And they are also coming from S2. The light waves are reaching this point from S1 as well as S2. So I call this point as P. So these are waves. Some waves are coming from S1. And few waves are coming from S2. When both the waves arrive at point P, they superimpose and will form a fringe. So can anyone tell me the part difference between waves arriving at P from S1 and S2? What is the part difference between the waves reaching point P from S1 and S2?
S2P minus S1P.
Very good. Part difference between waves reaching point P from S1 and S2. We can write that part difference as X, which is S2P minus S1P. That's my first equation. So our first task is to get the value of S2P and S1P in terms of small d and capital D and this Y. So see, what we can do is I can just drop a perpendicular over here. This whole is yn, this is d by 2. So this much of separation will be yn minus d by 2. And similarly, if I drop a perpendicular here, then see this is yn, this distance is d by 2. So this whole separation up to here, this will be yn plus d. Draw this diagram, then we will start the calculations. And let's name this point some, let's name this as n, name this one as m. Tell me once you have written it. Huh? Just draw the diagram. The entire derivation is based on this diagram. Written?
Yes, sir.
Yes, sir.
Okay. Now I need this part difference x. Huh? That's S2P minus S1P. Now let's first calculate S2P. So get S2P, I will use this triangle S2MP in triangle S2MP. S2MP. How much is S2P in this triangle? See, it's a right angle triangle, S2MP. How much is S2P? It's base square by perpendicular square, right?
Yes,
So
sir.
you can write your S2P as S2M square plus its PM square. So you can write S2P as S2M, which is capital D square. And see how much is PM? PM is yn plus d by d, right? From P to M. yn plus d by 2 whole square. It's 2p square plus d by 2 whole square. Or I can write S2p as it's d square plus yn plus d by 2 whole square to the power half. You can take d square as common here. If you take d square as common, this is 1 plus it's yn plus d by 2 square by d square to the power half. Next, you can expand it using binomial expansion. See, you can write 1 plus x to the power n as 1 plus nx. So this is 1 plus x to the power n. You can use this n here. So you will write S2p as it's d square 1 plus 1 by 2. It's
Sir,
Sir,
obviously this won't be square. This will be d.
sir,
Yes.
sir, how you got S2p square is equals to S2m square plus pm square?
It's a right angle triangle. Huh? S2MP is a right angle triangle. So this S2P is the hypotenuse, this S2M is the base, and PM is the perpendicular. Pythagoras. Okay. Yeah, is it clear?
Yes, sir.
yes, sir.
Sure. Similarly, I need this S1P. So which triangle I should use, Sania, to get S1P? I need S1 to P. Which right angle triangle should I use to get S1P? Sania, which right angle triangle should I use to get the value of S1P?
S1, P, S2.
I need S1P. Which right angle triangle should I use? This one, Sania. S1 and P.
Yes.
In triangle S1 and P, you can write that S1P square is S1N square plus Pn square. Pn square. So you can write that S1P is it's S1N square plus its Pn square to the power half. Next, what we can do is we can write their values. S1N. How much is S1N? S1N is D and Pn is Yn minus D. So it's D square plus it's Yn minus D by 2 whole square to the power half. And just like previous steps using binomial expansion, I can write this S1P as just like this, the previous one. It's D. It's 1 plus 1 by 2. It's Yn minus D by 2 square over D square. That is equation. If I call this as equation 1 and I let's say call this as equation 2, this is equation 3. Now you will put 2 and 3 in 1 and we'll get the value of x. Do it. Just note it down and then put 2 and 3 in 1 and get the value of x. Yes, written up to here. This S2P is over.
Yes, sir.
Then please put 2 and 3 in 1 and get the value of x. Good, Abdullah. That's x. Very good. Yes. Anyone else got the answer? Just substitute 2 and 3. Majority of terms will get cancelled out. Noor, Sania. Just do the substitution. Put 2 and 3 in 1. That's it. Okay, I'm doing that. See, when you do the substitution, 2 and 3 in 1, here, put the value of S2P. S2P is D. It's 1 plus 1 by 2. It's yn plus t by 2 by capital T minus S1P, which is D. It's 1 plus 1 by 2. It's yn minus d by 2 over d. So you can take d common from all terms, and this will be 1 plus 1 by 2 yn plus d by 2 over d minus 1 by 2 yn minus d by 2.
Sir,
Yes, right.
so you can give the d square
Okay, yes, it was d square.
and yn minus or plus d
Right,
by 2
right,
whole
right,
square.
right. That was the whole square. And this is square, and this is square, whole square, and this is square. So this one will get cancelled out. This is square, this is square, this is square, and this is square. So we are left with it's d 1 by 2 yn plus d by 2 whole square divided by d square minus 1 by 2. It's yn minus d by 2 whole square divided by d square. So from these two terms, you can take 1 by 2 d square as common. If you take 2 d square as common, you are left with yn plus d by 2 whole square minus its yn minus d by 2 whole square. So this d will cancel the square. You will get your x is 1 by 2d. It's a square minus b square. So just open the whole square. So it's a square plus d square by 4 plus it's 2 into yn into d by 2 minus. Similarly, open this whole square. So it's yn square plus d square by 4 minus twice of yn into d by 2. So see, when you cancel them out, yn square will cancel yn square, d square by 4 will get cancelled by this d square by 4. The similar terms and you're subtracting. This 2 will cancel this 2. This 2 will cancel this 2. And you will have that your x is 1 by 2d. It's y and d minus minus plus it's y and d. So it's twice of yn into d. 2 will cancel this 2 and you have yn into small d by capital D. So this is the relation that your part difference is yn into small d by capital D. Do it, note it down. Tell me once you have written. So this is the relation between, this is part difference. And this is the separation of nth fringe from the center maximum. Now using this equation, you can calculate the value of yn for the bright fringe and for the dark fringe. So you can calculate condition for bright fringe. Let's call this as equation number 3 is 4. See, for bright fringe, your x is n lambda. We have already calculated that part difference for the bright fringe is n lambda. I call this as 5. Let's substitute 5 in 4. So we get n lambda is yn into small d by capital D. So you can write that yn is n lambda capital D by small d. That's yn. Similarly, we have condition for dark fringe also. So say your It's n lambda capital D by small d. Your n will start from 0, 1, 2, and on. So when we put n equal to 0, we get y 0. So if you put n equal to 0 here, you get y equal to 0. That's for central bright fringe. This is the position of central bright fringe. See, we are calculating separations from the center here. We are calculating all separations from this center, central bright fringe. When I put n equal to 1, I get y1 equal to lambda d by d. That's for first bright. When we put n equal to 2, I get y2 as 2 lambda d by d. It's second bright. And so on. We can calculate the positions of all bright fringes. The next is condition for dark fringe. Condition for dark fringe.
Yes, sir.
Yes.
So in these conditions for dark fringe, that n is 0, 1, 2, 3, or starting from 1?
Starting from 1. Well, that depends what part difference you are using. Since we use 2n minus 1, right?
Yes,
2n
sir.
minus 1 lambda by 2. N will start from 1. But instead of this, if you write 2n plus 1, then your n will start from 0.
Okay, sir.
Let's call this as equation number 5. 5 is over. Let's call this as 6. Let's call this as 7. We will substitute this 7 and 4. So when substitute 7 and 4, we will get, instead of this x, I can substitute 2n minus 1 lambda by 2. Is equal to n y and d by d. Y and small d by capital D. So we can write that yn is 2n minus 1. It's lambda to capital D by 2 into small d. That's why. And your n will start from 1 and it will be 1, 2, 3 and all. So when I put n equal to 1, I'll put n equal to 1 here. I will get lambda d by 2d. That is the condition for first dark. Then we can put n equal to 2. When we put n equal to 2, I get y2 is, when I put 2 here, it's 3 lambda d by 2d. That is the condition for the second dark. Similarly, I can put n equal to 3 here. I get y3. When I put n equal to 3, it's 6 minus 1, 5 lambda d by 2. This is for the third dark. So this is how we can calculate the position of dark fringes. There is one last term, which is the width of central maximum. Width of bright fringe or dark fringe? Width of bright fringe or dark fringe. So in interference, both bright and dark fringes have same width. Both have same width. This is lambda d by d. This is the width of bright fringe as well as the dark fringe in central maximum in interference. Just note it down.
Sir, can you scroll up?
Yes, yes.
Done, sir. Thank you.
I think it's scroll a little down.
Yes, yes, yes. They
Sir?
just, yes.
What's the last formula?
This is for the fringe width of right fringe, lambda d by d. The fringe you are
Well,
getting here,
that is beta or
beta. Yes, we represent fringe width with beta.
okay.
There are just two more relations. One is angular fringe width. See, angular fringe width is nothing. You are expressing fringe width in terms of some angle, theta. It's just fringe width divided by the capital D term. So it's lambda capital D by small d into capital D. It gets cancelled out. It's lambda by d. So this is angular fringe width, which is lambda by d. After angular fringe width, we need a fringe width in liquid. So if you immerse the entire apparatus in a liquid, then fringe width in liquid is fringe width in air divided by the refractive index. These are small conceptual questions that one can ask on it. Just note it down. Yes, Abdullah, class is over.
Thank you, sir.
Sure, okay. Thank you.
Thank you, sir.
Sure, okay. Thank you.